Welcome to H323 Configuration Heaven. In this nugget, we are going to go through scenario after scenario of H323 configuration. I've got my next slide shows all the different scenarios that we're going to walk through, but by the time this nugget is done, you should feel solid on many H323 configurations on a Cisco router. As you can see, I have quite a few configuration scenarios set up for H323 because H323 is one of the core protocols that Cisco routers run, and it's the default protocol that they run, and so on. So I'm not going to do it all right here. I have individual slides for each of these to bring up a network diagram and walk through how we would configure that scenario. So I'm going to start off with voice over IP dial peers and call manager redundancy. Look at using multiple codecs per dial peers and tuning voice service parameters and allowing voice over IP to voice over IP style connections. We'll do a toll bypass configuration. A lot of people call it THO, tail end hop off, to where you route calls over the WAN to use somebody else's PSTN connection for free long distance. And then we'll look at call manager integration, tying it in with call manager, and finally DTMF relay. So here we are in configuration scenario number 1. Our goal is to create voice over IP dial peers using H323 in such a way that we have redundancy, to where maybe we have calls coming from the PSTN into the router, and the router needs to route those calls to the call manager, which will allow it to get to the phones, and that'll be for incoming and outgoing purposes. It needs connections with that call manager. But if this call manager should fail, we want that gateway to fail over to this guy and use that one appropriately in a reasonable time frame. And I say in a reasonable time frame because I always, through these scenarios, you'll see me just put little notes like this for myself because of the H225 timeout parameter. When we get into the configuration, I'm going to explain that to you and tell you by default it will be able to be redundant, but it will not be in a timely fashion. So more on that in just a second. So here's the scenario. We've got internal extensions. Let's say these are all the two ... extensions. So 2000, 2001, all two ... extensions internally. What I need to do is I need to go to my gateway, my 2801 voice router, and I'm going to create voice over IP dial peers to connect to those Cisco call managers. So I'll do dial peer, voice, and we'll do the tag. We'll just say 20 for representing digits 20. Well, I'll do 2000. How's that? 2000 will be my tag, and the tag can be anything, and it's going to be a voice over IP dial peer. This will be to allow this router, as it receives calls from the PSTN, to send them in to the internal extensions. Now, let me talk about the scenario just a little bit more before I do that. I'm assuming in this case that we have a DID range. Let's say our external phone numbers is 480-555-2XXX, right? And that's a DID block from the public switch telephone network that when anybody on the PSTN calls that number, they will actually send in a 4-digit extension. Most service providers, not all, but most of them, will strip this down to where they'll just send you a 4-digit extension to your router, like 2001, which your router will receive it, use direct inward dial to send it to the call manager, and then send it over here to the phones. Now, we'll talk about later, well, what if they don't give you the strip number? How, can you strip it on the router? And the answer to that is absolutely you can, and more on that later. So once I receive that 2... call, I'm going to say that pattern, that destination pattern, is going to be routed over to the session target IPv4, and this will be the call manager's IP address, 172.30.100.104. Now, if you think back to the previous nugget, I talked about the H323 defaults. This is my primary call manager. I want it to go to this call manager first before it shoots over here to call manager number 2. Now, when I create a voice over IP dial peer, the default preference is, you remember, 0. It's 0 through 10 is the preference. I think I said 0 through 9. But 0 through 10 is our preference order there. So we can have up to 11 different dial peers, 0 through 11, that we can have going to the same destination. Again, the lower preferences are preferred. Now, I want you to check this out. I'm going to type in, exit. I'll do a show run section. Let's do dial peer. you haven't seen that section command before, boy is it handy. So you can see all the dial peer sections, and right here there's my dial peer voice 2000 voice over IP, and notice 2 ... session target IPv4. Wait a sec. Where's our preference 0? It's not there. The reason it's not there is it's default. I can type it all day long. It will never show up because call manager the router considers that a default command, and just like no shutdown, it's not going to show you no shutdown under an interface because that's assumed a default. It's not shut down, or it's preference 0. So watch this. I'm going to create dial peer. Let me just hit the up arrow a couple times. Dial peer voice 2001 voice over IP. Destination pattern to ... identical destination pattern. Session target IPv4 colon, and we'll do same IP address with a 5 at the end, because that is going to be our secondary call manager, this guy 100.105. But I want to make him the second preference, which in our case will be preference 1. So the only time it's going to use dial peer voice 2001 and this IP address is if it's unable to connect and route an H323 call to dial peer 2000, which is preference 0. Let me do that show section dial peer command again, and you can see that I've got 2001 right there. Notice preference 1 shows up because that's not the default. It's only going to use this if this one is unavailable. Now, that's going to work. That means when I receive incoming calls from the PSTN, and we haven't set up DID yet, that's later, but when I receive incoming calls from the PSTN to this router for extension 2 ... I'm going to receive them and route them to this IP address first, followed by this IP address. But there's a problem. And that goes back to our H225 timeout. By default, H225 will attempt to connect to this call manager for guess how long? 30 seconds. Meaning, it's going to send a setup message saying, hey, I got an incoming call. And it's going to sit there and wait. It's like, wow, no response. Well, let me just wait. Maybe he's busy. Maybe he's out to lunch. Let me just wait. Time's ticking. This guy out here who made the call into your network is waiting. He just hears silence. Now, if this person is patient enough to wait 30 seconds, it will then say, oh, okay, this guy must be down. Let's flip over to this call manager. But do you know how long 30 seconds is? That was 3 seconds. You're probably like, something's wrong. Wait, it didn't go through. The audio cut out. CBT Nuggets failed. Like as soon as I was silent, you immediately, alarms are going off. And that same feeling happens for people dialing in from the PSTN. When they dial in, they're expecting that nice ring signal, that comfort tone, that something's happening on the other end. If they dial and just hear nothing, they're going to freak out. So what we need to do is we need to change that timer down, definitely from 30 seconds to a lesser value. The way that we do that is by using something called a voice class. It's kind of a funky configuration. Cisco makes everything modular, which is good sometimes, but sometimes I'm just like, come on, make it a little easier to do this. Here's the idea. You go into global configuration mode and type in voice class, and you can see we've got all these options, H323 parameters, and then you have a little tag. And this tag is one that you'll want to remember. It can be any number between 1 and 10,000, but you'll want to remember the number because this will be applied to a dial peer. So check it out. I'll use tag number 50. I'm in config-class, and now I'm going to say the H225 timeout for the TCP connection, because that's going to be what it's waiting for. It's TCP base, port 1720, so it's going to try and connect to this call manager, send a little TCP SYN message, and it's going to wait 30 seconds. Just so you know, that's the default on your router for all TCP connections. That's what it does. Have you ever tried to telnet or SSH to an IP address that's not there, and your router just hangs, and you're kind of like, okay, I mistyped the IP address, I'm sorry, please give me my prompt back. And it's going to hang there for 30 seconds because it's waiting for that TCP SYN ACK message to come back. So in the same sense, I'm going in and I'm saying to, change this timer. The timeout value for TCP established is not the default of 30. Let's go for, totally. Let's go for 2. That's a pretty safe value. I mean, if you send a message TCP wise and it doesn't come back for two seconds, that's a problem. I mean, either your call manager is just swamped to the point of not being able to respond, or there's some kind of network failure or network issues that are happening. I'm tempted to even go lower, to adjust it down to 1, but some people might yell at me and go, "Oh, that 1 second, that might cause a false failover." And you're right. Maybe there's a problem, but even 1 second. I mean, for packets traveling at the speed of light, a second is an eternity. So we'll say 2 seconds, right? So now I'm going to go back under my dial peer. Dial peer voice 2000, voice over IP. And I'm going to apply that voice class. I'm going to say voice, it's dash class. You create them with voice space class. This makes sense, right? Create them with voice space class, and then apply them with voice dash class. So voice dash class, H323, and then whatever your tag number is, 50. Good? Check it out. I'm going to do a show run. Look at my section dial peer. Now, do I need to apply that voice class under the second dial peer I created? No. Because if it's, now, let me back up. If I had a third or fourth or fifth call manager that I was routing to, then yeah, sure, you'd have preference 2, preference 3, and you'd want it, to try this one for 2 seconds, and then if that's down, go to this guy for 2 seconds, and if that's down, keep going. But in this case, I only have 2 call managers, so I'm only applying that 2-second timeout to the very first dial peer. So if it can't reach this guy for 2 seconds, then it's going to fail over to this guy, and at that point, I don't care. If it can't reach that guy for more than 2 seconds, I'm dead in the water anyway. Both of my call managers are down, so that call's not going to happen. So here's what happens. Person calls in from the PSTN. Call comes to the gateway right here. It's going to try to connect to this guy for 2 seconds. If that fails, it's going to fail over to this guy, and that call should go through should the call manager be running. Is that a good time? I'd say yeah. I mean, when you pick up a call, here's a 2-second emulation. Okay. That's our 2 seconds. So that's a reasonable amount of time for a failover to happen. Now, if you've got multiple call managers, like second, third, fourth, and I shouldn't even go there. I mean, if you've got 2, 3 call managers down in your network, you've got bigger problems than just a call coming in from the PSTN. So that's setting up voice over IP dial peers with redundancy and a reasonable failover timeout. All right. In this second configuration scenario, here's the scoop. We've got a router over here on the left. This is our router. And we are creating a voice over IP connection to this router, which connects to multiple networks. We've got, network A over here, which goes to some group of phones, network B to another group of phones, and network C to another group of phones. They're all voice over IP phones. We're staying IP connection fully. You see the WAN there that we're going across. But the problem is we don't know. I mean, we're just saying we don't know about the specifics of any of these networks over here. This router does. We just want to create a dial peer that says to get to those phones over there, point to this router, and then it will direct you the correct way. It's kind of a little gateway to all the other voice over IP networks. The problem is that some of the phones use different codecs. Like maybe in network A we use G.711, network B we use G.729, and network C we use maybe that's G.729B. Meaning that's got the VAD enabled and all that kind of stuff. And the problem is, we don't know the specifics on all these. All we know is that there's 4-digit extensions over there. Maybe this router knows that 3 ... is over here, 4 ... is over here, and so on. But on the left router, we don't know and we don't care. Well, this router maintains all that, so we just want to send any 4-digit extension ... over here, but somehow allow it to use different codecs. Now this poses a problem initially because here, let me just clear off our last scenario here. It poses a problem initially because when we create a dial peer, let's say I do dial peer voice, let's do 70 voice over IP, and I'll say the destination pattern is ... 4 dots. The session target is IPv4 colon, and we never gave this guy an identity, so let's do that. We'll say he is 10.5.1.9. We'll just throw an IP address on him right there. So that's his IP address that is assigned to that interface. So I'll come back over here and say 10 dot, what did I say? 10.5.1.9 as the session target. So we've got the dial peer set up for the 4-digit dialing, but now, I mean, here's the problem. We type in codec, question mark, and we can only assign one codec. I can't say, you know, like G711, ULAW, which is used in the, I always remember that, United States of America, or A-Law is another place in the United States of America, and Japan. Japan also uses ULAW. You can't say, you know, G711, G7, you can't make like a list. You see my point? You can only hard code one codec under the dial peer. So how do you allow it to kind of rotate, you know, and say, well, you know, try G711 first, and then try G729A, and then try G729B down here at the end, if that's not working out? How can you kind of rotate between them? Because, you know, if you hard code G711 and you end up going to network A, then you're good. But if you go to network B, you're going to get a fast busy signal because you have a codec mismatch. Well, this is a job for something called voice class codecs. Very similar to what we just saw with the H225 timeout. I need to go into global config mode. I'm not going to hard code any codec under the dial peer. I'm going to exit out, go into global config mode, and type in voice class codec, and then you give it a tag number. That's why I said it's kind of similar to what we just saw. And we'll say, you know, number 10. Voice class codec tag. And then you go in here and say what your codec preferences are. Notice I'm going to type in codec, and the preference for this one will be 1. Highest is the lowest. So 1 is the highest priority. I wish they would do this on every context-sensitive help. Wouldn't that be so handy? There's so many things where it's just like, guess. You know, higher is better sometimes, lower is better sometimes. So 1 is the highest. And I'm going to say my first priority codec will be G711 ULAW. Codec preference 2 will be G729 R8. And then codec preference 3, you know, G729 R8 will be G729 or G729A. It kind of uses either or depending on what the other side is. And then codec preference 3 is G729 BR8, which is G729B. Enter. It says, by the way, you know, codec is negotiated, VAD configuration, blah, blah, blah. That's just saying that if you hard code the VAD under the interface, its VAD configuration will be discarded. So I'm going to go under the dial peer voice 70, and I'm now going to apply this voice class codec. And just like the previous configuration, it's a dash now. I'm going to do voice dash class. You create it with voice space class, apply it with voice dash class codec, and then we type in our tag number, which was 10, I believe. Good. So that will allow us to now rotate around between our codecs and apply the one that is most appropriate. You can see dial peer voice right there, voice class codec 10. So it will rotate, it'll try G711 first, then G729A, then G729B. Now we move into configuration scenario 3. I guess you can call this my miscellaneous configuration scenario, because I want to show you one big one, which is the allow connections command, and then just a bunch of H323 kind of miscellaneous parameters and things that can come in handy for you. So here's the scenario. We've got an H323 gateway with a connection to 2 different call managers, similar to what I configured before. Whoops, that'd be a duplicate IP address. 2 different call managers there. And it has a connection, we'll say using a PRI line or T1 line, CAS, to the PSTN. Now, it also has a connection across the WAN to some other office. You know, it's not pictured here. You know, you got the office here with some call manager or phones or whatever. And that office has a connection to the PSTN as well. Now, it just so happens in this scenario that the connection to the PSTN is either, we'll call it full, or it is down. It has failed for some reason. What you might want to do at some point is to say, well, you know what, if that's full or it's down, let's go ahead and reroute calls over the WAN to this gateway, if our WAN is still online, and use its PSTN connection for our calls. Now, a couple warnings before you do this is there's a lot of considerations you would have before you did something like that, like emergency calls, like you don't want 911 or some emergency code call to come out here and emergency trucks to show up there, so you might deny those or reroute those somehow to maybe a local FXO port or something like that. And there's always caller ID information, and there's a lot of considerations you have to think through before doing this. But what I want to focus on is the commands and the syntax to make it happen, because the problem is this. By default, you were routing calls out the PRI line. Like when somebody in this office made a call, they would go out through the call manager to here and go out this direction. But when you rerouted, it now goes from a voice over IP connection to the router to another voice over IP call over here. By default, that is denied, because it sees that as kind of a tandem hop, meaning this router is taking a responsibility for an IP call and then tandeming it over to another router, which can cause some delay considerations and things like that, but most of the time it's okay. It's denied by default because it came in as an H323 call and then it's going out as an H323 call to another gateway. So if you want to allow those connections, you can see my syntax here, allow connections. Here's the command you want to do. I'm going to take you to the router. Let's clear off the last scenario. Move into global configuration mode, and you type in the command voice service voice over IP. Now this is kind of the, I guess you could call it the registry, to make a Windows comparison. It's like the registry for your voice over IP service. It contains all the miscellaneous stuff that Cisco just was like, let's throw it in there. It doesn't really fit anywhere, so let's just toss it in there and allow that to happen. So here's the command. You can see it right up top, allow connections. You type in allow connections space, and then you say, well, let's do H323 to H323. Enter. That's the one command that will allow this scenario to work. Until you do that, it will not allow incoming H323 calls to relay out as another H323 call. It always has to go H323 to POTS or something to that effect. Now you can also see in here we have like H323, we could go to SIP or SIP to SIP. There's different things that you can do, and that's really, when you configure it that way, you're defining an IP to IP gateway. You might remember that from some of the opening nuggets of this series. That's what an IP to IP gateway can do, is translate between those signaling protocols. And when we get to the IP to IP gateway, I'll come back here and bring that up again. But that is how you allow those kinds of connections. So now let's get into the miscellaneous commands. Let's talk about where weird stuff can happen. By default, here's our weird thing number one. By default, the H323 gateway sends keep alive messages using H225. It's sending little TCP keep alives, just making sure that this gateway is online and life is good. So here's the problem. And it may not be a problem, may be a problem. You've got a call going from an IP phone in your network out to the PSTN. People are talking, you got, maybe 5 active calls going out to the PSTN. People are talking, life is good, and all of a sudden, meanwhile, the call manager fails. Call manager goes down. Now, the gateway is maintaining these H225 keep alives, and if they fail, meaning it's detecting that the call manager is gone down, and let's say this is a remote office or something like that, there is no secondary call manager, this is going to kick over to SRST mode. If you have survivability set up to where this gateway will run the IP phones. But the problem is, in the transition to SRST mode, it will drop every single active call. That's just that's a feature. When it detects the call manager fail, it says, "Oh, you're down. Sorry, we're dropping every single call." Now let's continue the story. SRST mode takes over. All these angry people are like, "What just happened? Let's call back. This voice over IP system. What's the problem with it? Blah blah blah." They throw out all their bitter hatred, and they make their calls back. And all of a sudden, this guy reboots. Maybe it crashed. It comes back online. SRST detects that H225 keep alives are successful, and it flips back over to using the call manager again. What's it do? Drop all active calls a second time. Ouch. So That's usually not a good thing. You don't want that to happen. And these H.225 keep alives, while they're useful, they're not necessary for the gateway to detect that SRST mode needs to be enabled. The phones actually detect the call manager is down and fail over to the SRST gateway to use it. You don't really need the gateway to detect if the call manager is down. So one of the handy things that you might want to do to keep active calls active should there be some call manager failure that it needs to recover from, you can go into, where's my router? Move into global config mode. And you type in, I could have just stayed there. Voice service, voice over IP. That's where the miscellaneous connections are. Go under H323 and type in no H225 timeout keep alive. Enter. That's it. That turns off the keep alives. When the call manager fails, it will not detect it from the router's perspective. It will not cut off all the active calls. The active calls will keep going. The phones will fail over with SRST, and they'll detect when the call manager comes online themselves. It's no worries. It's just you're turning off that keep alive parameter to allow that failover to happen. The last two parameters are truly miscellaneous commands. They don't really fit into this scenario specifically, but you may end up using them at some point in your voice career. Just stash them in the memory banks, throw them on a notepad or something for future reference. The first one is from this H323 configuration mode. Move into voice service, voice over IP, hit H323, and the first miscellaneous parameter is call service stop. That's pretty straightforward and self-explanatory. It stops H323, because that's the mode we're in, H323 call processing. This might be useful. Maybe you're transitioning this router from H323 to SIP, and you've created all the dial peers for SIP. You put them with higher preferences so they won't be preferred, and you're ready to make the cutover to allow this to work. You want to turn off H323 on the whole router without removing all the H323 dial peers, because maybe you want them to still be there in case you have to be like, oh no, I didn't think of that, and you have to revert your configuration back. Well, this stops H323 call processing. If you do that and you're like, oh no, I don't have SIP ready, I need to revert back to H323, just throw a no back in front of it, and then H323 call processing starts again. The last parameter is to stop fast start. Remember I said that by default, the router will use H323 fast start when communicating with other devices to combine the H.225 negotiations and H.245 into a single exchange. It just allows the call to start up faster and the exchange to go faster. Well, there may be times where you might be in an environment that maybe has equipment that doesn't support fast start, or you just don't want to use it for compatibility reasons, or it's just not working for you. You can do a call start slow, and that moves it over to slow start away from the fast start default. And if you want to flip back over, you can always just jump back over to fast. Now we move into a toll bypass configuration scenario. This is very common between companies that have offices in other regions, especially international. Long distance charges have come down to dirt cheap in the United States over the last few years, because long distance carriers know that this is coming, and voice over IP is taking over the world slowly but surely, and eventually long distance toll charges will be all but gone. So a lot of times you see international offices doing toll bypass, because that's where you really start seeing some cost savings. Like, let's say we've got an office or an organization who has an office in Phoenix and an office in Australia. Right. And we've got the Australian folks over here that are still on a PBX system, but we've got them connected to a router that has a bridge over the WAN to Phoenix, and we want to do toll bypass, allowing these PBX calls to route into the router, over the WAN, into Phoenix, and then out Phoenix's PSTN connection to totally save all toll charges, not only inter-office calls, but Australia can now call anyone in the Arizona area, Phoenix, Tempe, Mesa, all of our local cities here, without paying any toll charges at all. So what you would do is, on the Australia router, I'm just going to show half the configuration because the other half's pretty self-explanatory. On Australia, you would move into global config mode. And I'm already there, and create a dial peer voice, and let's do a tag of 1480, which is one of the area codes in Arizona as my tag number, and I'll use voice over IP. And I'm going to say the session target is going to be the Arizona router, which happens to be 10.1.1.1. So from Australia's perspective, it's going to send calls to 10.1.1.1 that belong in Arizona, and I'll do destination pattern. We'll do, and I'll leave out any access codes like 9 for an outside line. I'll just do 1480 ... That's a typical Arizona extension. So when somebody picks up the phone in Australia, dials 1480 something something something, that's an area code in Arizona. It's going to route over the WAN. Now, I can then go through, and I'm not going to create them all, but I would create one for every area code that is local to Arizona. 1602, and I'll do destination pattern 1602, and session target IPv4 Truth be told, you might decide, if you've got an office in Australia and an office in Phoenix, to route all calls to the United States over the WAN to Phoenix, even though it may be long distance from Phoenix. Maybe you're calling New York City from Australia. It's a whole lot cheaper to route over the WAN and come out the Phoenix PSTN connection and pay long distance charges than it is to go direct and pay long distance charge to New York City from Australia directly. So you may choose to route the whole North American numbering plan over the WAN, and that's totally fine. I'm just showing you one example here of creating a toll bypass just for the Arizona area. You would, route your, let me just show you here. You would create route patterns like this. This is a entire North American local scheme, entire North American long distance scheme, and you would route those over the WAN from Australia's perspective. But I'm just doing two for this example. Now you'd want some redundancy in there, so you might do dial peer voice. We'll do 1480, but we'll do 1481 as a unique tag to just say, this is the redundant one for it. And we'll do this one as POTS because Australia still has its own PSTN connection. So if the WAN is down to Phoenix, we might want to say, well, you know what, we're still going to pay the toll charges internationally, but at least we'll get some service. I can do the destination pattern, and we'll do same destination pattern, 1480 ... Set the correct digits for it, yep. And then I'm going to do preference 1. To say only use this one when your preference 01 is down, because now you've got a duplicate dial pattern here, or dial peer. And then remember, this is a POTS dial peer, so it's going to automatically strip any explicitly defined number. I'm going to say no digit strip to say don't strip any of those digits when you send it out, because that area code is relevant. And and we're in Australia. I don't know Australia's dial plan, so we would probably have to type in like prefix, prefix whatever digits you want to prefix onto there. So I don't know, 9999. What do you dial in Australia to reach the United States? I don't know, but that's what you would prefix onto the front of that number there. So somebody dials this, it's going to try the WAN first, 1480, try that dial peer to go there. If that's down and it fails, then we're gonna fail over, and we're gonna try this one. It's gonna say, well, don't strip any of those digits. Add on 999 to the front, which is however you get international calling in Australia, and then send the call. Now keep in mind, let's go back to remember configuration scenario 1. By default, this Australia router is going to try Phoenix router to try and connect there for how long? You remember from scenario 1? 30 seconds. So we would also want to reduce the H225 timer, the timeout for this dial peer to say, only try that for 3, maybe 4 seconds. We can increase the time since it's international. There's more delay there and that kind of thing. But you definitely want to increase that. Otherwise, if the WAN is down, it's going to take 30 seconds to reroute the call over the PSTN, which will not lead to happy Australia people because nobody waits that long. So that's just an example toll bypass configuration. By the way, this is also called THO. You'll see it abbreviated that way all the time. Tail end hop off, where you're coming across the WAN and then hopping off at the tail end to the PSTN connection. I'm just going to leave it at that. I'm not going to go through and do the same thing for 602 or all the other area codes that we have there. This shows redundant connections for each one of those. Oh, and I forgot. You can see it's down because I forgot to add the outgoing port. We would want to send it out our T1 line or FXO port in that case. All right, now we move into some final configurations. They don't really need a full scenario because they're pretty straightforward. They are configuring call manager integration with H323 gateways, and then finally, DTMF relay with H323. So call manager integration is where you have the ability to route calls to and from a call manager system to an H323 gateway. And this might be where you got, a router here going to the, PSTN, maybe it's a T1 line. You've got a couple IP phones sitting on the network. These are all IP phones. And you want calls to route from these IP phones through the call manager to the gateway and out to the PSTN, or from the gateway to the call manager and to the phones. Either way, the call manager system has to know about this gateway. And I did this in the last nugget. I just hit it. I said this is going to be coming up in the next one. I'm going to skip this part when I was showing you the debug of an H323 call between an IP phone and the PSTN and what that looked like. So let me show you the call manager side. It's really easy because H323 is a peer-to-peer protocol. So from the call manager's perspective, there's not too much to it. You just say, hey, there's a gateway over there. Here's its IP address, and you can send calls to it if you want to. It's not like MGCP where you have to define every port. So I'm under Device Gateway on the call manager, and I've removed all my gateways. I'm going to click on Add a New. It comes up, gateway type. We have all of these types, which if I want to use MGCP, I choose the actual model number. But you might remember from the MGCP nuggets, if I want to use H323, no matter what model of Cisco router I'm using, I just choose H323 gateway and hit next. This is where it's so simple it's almost funny. I go and put the device name, and this is where I type in what the IP address is of the remote gateway. I'll do 172. Oh, I actually have it right there. 172.30.4.3. That's the IP address of my H323 gateway. And then I choose a device pool, which in Call Manager is how it knows what call managers will be supporting that gateway. And it talks about, with device pool, and this is also again from CIPT, you would set the region, meaning the codecs that you use when you're talking with it, the date and time zone. There's all kind of stuff that it's a pool. That's the point. Pool of configuration. I'm just using default for everything since this isn't really a Call Manager class. And I click on Save. Click on Save, and that's it. I click on Reset to reset the connection with the gateway. It kind of solidifies it in the Call Manager database, reinitializes that connection, and we're good to go. At least from one perspective, the gateway can now send calls to the Call Manager, and the Call Manager will recognize it and say, oh, well, you're one of my known gateways. You are 172.30.4.3, which is in my database, so I will process calls from you. Now you might wonder, well, how does the call manager know to send calls to that gateway? Well, it doesn't yet because we haven't defined any dial plan at all in the call manager. We've just said you now have a gateway. Here's the gateway. Its status is unknown because call manager doesn't do keep alives with it. It just says I have this gateway and I'll use it if I need to. So if I wanted to, I could define a route plan. Now this gets heavily into the CIPT course where you can create a pattern which points to a list, which points to the group, which points to gateways and set up redundancy and all that. I'm not going to do that here because that's a huge discussion. I'm just going to create a pattern. I'll click on Add New, and I'll say anything that begins with 9, that's an outside call, and I'll put .at, and you see my little history right here. 9.at will go to the gateway 172.30.4.3. And check this out. You even get the provide outside dial tone. It's pretty slick. Now you might wonder, well, what on earth is that? What is 9.at? The at symbol to Call Manager represents the entire North American numbering plan. It's any number that you can dial in North America. I usually call that the lazy way to create a PSTN dial plan. It's not the best, but it works. And so that says now anything that, if you have an IP phone that dials 9 dot in any North American number, send it to that gateway. And last thing I'll put in there is I want to discard pre-dot. That explains why I have the dot in there. See, I have 9.at, and I want to discard that digit pre-dot, it's before the dot, before I send it to the gateway. That's what this called party transformation and discard digits are. What I'm doing right here, if you're studying for certification, you don't need to know the call manager side of it. That's part of the CIPT series and the certification exam. That's just, we'll call it bonus. So I'll click on Save. Oh, forgot the numbering plan. North American Numbering Plan, NANP. Save. And OK. Just saying the authorization code isn't defined. This gets into where you can put force authorization codes, and people have to dial a code before they can get out, and that sort of thing. But that does it. I now have the ability to call from the IP phones any North American number, and it will route it over here to the gateway. All right. Last thing I want to talk about is DTMF relay. By default, Cisco router will send all DTMF tones in the codec bandwidth. Meaning, if I've got a router here connected to a router there over the WAN, and maybe this is the PSTN. We've got the phone over here. All of the digits that are dialed, DTMF tones, are sent in the codec bandwidth, which if you're using G.711 shouldn't be a problem because it's sending the full bandwidth for the call. The tones should be interpreted at the remote end and thus on the PSTN without any problem, and life should be good. But if you're using compressed codecs like G.729, DTMF tones get scrambled. So we have to have a way to send them out of the bandwidth. Now if you go into the dial peer configuration mode. Let me clear all this off. Let me do a show dial peer voice summary. Give me a good voice over IP dial peer. There we go. Dial peer voice 2000. Go in there. You have the command in H323 of DTMF relay, and then you get to type in a mode. There are 4 different modes that are supported by H323 and Cisco routers. Cisco RTP is a proprietary method. It actually sends it in the RTP stream, but it codes it differently. It's actually using different, it's known as H323 payload types. It uses a different payload type to code it so that it recognizes the tones at the other end. Now, in order to run that method, you have to have Cisco routers on both sides supporting that mode. Now, there was an industry standard event that was created in RFC 2833. This is actually an older RFC standard that used named telephone events. It's essentially the same thing. It uses a different event style or a different payload type to identify those digits, but it's an RFC standard so that you can use it not just with Cisco routers but with other vendors as well. Those two methods, I mean, you might see Cisco RTP used here and there, but those two methods by far are, dwarfed, if you will, by these two. H245 alphanumeric and H245 signal. H245 alphanumeric sends the digits outside of the codec bandwidth, not using any special payload type or codes or named telephony event or telephone events or anything like that. It just sends them using H245 signaling. You remember when we talked about the signal types, H225 sets up the call, H245 negotiates the feature. Well, they said, well, we've got this protocol. It does feature negotiation. Why not just let that relay the DTMF tones? So H245 alphanumeric is able to relay the tones themselves, but not how long you hold down the button. Meaning, if I dial 1, 2, 3, 4, 5 on this phone, it will say I'm passing those using H245 alphanumeric signaling. I will pass those, but it does not record. Like if I hold down 1 and go beep, for 3 seconds, and then 2, 3, 4, 5, it's not going to reflect that. If I'm listening on the other end, I'll just hear beep, 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 beep. 1, 2, 3, 4, 5. Each tone is assumed to be 500 milliseconds in length. So no matter how long you push them, it just rounds them down to 500 milliseconds. And for most implementations, that's cool. I mean, who cares how long you hold down the button, or unless you really want to annoy someone on the other end. You're talking to somebody, they're annoying you. You're like, you know what, beep, and just you hold down your button. You're not going to get any satisfaction doing that with H245 alphanumeric, because all they hear is a beep, and they'll say, well, you feel better now. The H245 signal addresses the problem with alphanumeric. It is the same thing as alphanumeric, but now relays the length of the tone. Now, there's other reasons other than annoying people that you would want the length. Sometimes when you're calling someplace using a calling card, you might type in, your code to make a call, and you place your call, and you're talking to the person, and you hang up, and it says, okay, would you like to make another call with the same calling card? Hold down the pound symbol for 2 seconds, and you hold it down, and that way you don't have to redial all your codes and entries and so on to use the calling cards. If you're using alphanumeric, it won't relay the 2-second hold down of the pound symbol. The H245 signal does. So, if you're not sure which method you want to use, you can actually type them all in. I can say, well, I want to use H245 alphanumeric, and then, H245 signal, and then, you can see, you can type them all in. Cisco RTP and RTP NTE. And if you do that and hit enter, it'll try all of them, and whatever one the other side supports will end up working. Now, here's the irony. You saw we typed them in order, right? I said H245 alphanumeric, signal, Cisco RTP, and RTP NTE. Let's go back here. I'm going to do a show run section, and then just paste that in. Dial pair voice 2000. Oh, take a look at that. I'm shocked. I'm stunned. Because I guess that's a new feature. The older iOS versions would actually rearrange all of that. I haven't tried it in this iOS version, so we're all learning here. This is version 12.4 release 15T5, which is a pretty latest and greatest version, but now I can say it maintains the order. In the older iOS versions, it would actually rearrange them to a preset order. It would always do Cisco RTP first, followed by RTP NTE second, then H245 signal third, then alphanumeric fourth. But apparently doesn't do that anymore. And that's great, because the old way was kind of lame, because if you wanted to handle all four, you couldn't really specify what order it was in. It always would try the Cisco proprietary one first, but now that has been fixed. So that is the DTMF relay, the 4 different methods that you can use on an H323 call. These troubleshooting commands I'm going to leave here for your reference. I was thinking I'd go through them and show them all to you, but there's a lot of them. Let me just tell you in general what they are. Show dial pair voice summary. I've been doing that one all the time, which shows you a good snapshot of all your dial pairs that you have. Matter of fact, okay, I said I was going to show them, but now I got to show them. At least this one. Show dial pair voice summary. Gives you a snapshot of all your dial pairs, where they go, their status, if they're up, if they're down. You can see this one's down just because it doesn't have a port assigned to it and that sort of thing. This is a way that you can just see all your dial pairs. Show dial plan number, and you can actually type in a number after that, will show you what dial pair matches a specific number. It's a cool way to test your dial plan without actually making any live calls. It will say, this number goes to this dial pair. Debugs, you can type in debug CCH H323. This is actually control channel for H323. H225 or H245 to see the signaling, and actually this in the newer iOS versions is optional. You can type it either way. I just usually type debug H225 and H245, but either one will work just fine. This is a dump. If you're this guy right here on a sinking ship and you're like, I've tried everything, I don't know what the problem is, show me every single thing that's happening. This stands for Call Control API, Application Program Interface, in and outbound. If you type that command, brace yourself, because you're going to get every digit, every signaling method. I mean, your screen will flood with information. That's one of those ones that you're in risk of flooding your router if you type it on a busy router. And usually, you're just going to get so much information, you're going to be like, too much. It's almost too much. So that's a last resort. Debug TCP transaction will show you your TCP sessions if they're succeeding and failing. That's good since H225 rides on top of TCP 1720. This is a hidden command. Let me just like the last slide. Let me see if they show it to you now on the new routers. No, it's not. CSIM. Take a look. It's not, you type C question mark, it's not in any of the context sensitive help, but this stands for call simulate. I want to simulate a call to, and you can type in csim start, and we'll do 1480, blah blah blah. And what it will do is simulate an actual call. Like if you've got a phone attached, it will ring. It's pretty cool. The reason they hide it, if you search on Cisco's website, is they say this command has been known to crash routers. Gulp. I can say I've never seen it crash a router, but they say it on Cisco's website, and they're still obviously hiding it in the iOS context-sensitive help. So I'll say use that one at your own risk, but that's what it does. Last but not least is the Show H323 Gateway, which will show you all of the stats. This is kind of your stat board for H323, how many messages you've received for setup, and you can really just kind of see how's my gateway handling. This is Gatekeeper. It's everything H323. It gives you just a stat chart of all your signaling messages that you've sent and received. Thus we have walked through H323 configuration heaven. We have gone through just configuration scenario after configuration scenario, showing all the different possibilities and ways that we can tune H323 calls. I hope this has been informative for you, and I'd like to thank you for viewing.